So now I want to give a brief introduction to Centaurus device. Centaurus device is something that you use to do the device simulation. Right? Once you have the structure, it's just like in the lab. People have made a wafer and they pass to you, and you want to do measurement on the chip to find the IV curve. So let's just pick the basic one. In this case, I'm going to double click this node. And then I will look at the command file. So in this file, it's just like, imagine that you are a device engineer. The fab has passed you a wafer, and though you want to measure it to get the electrical characteristics. So you see that it has several sections. Each of these sections are not related to, are not in sequence. You can swap them in any places. Each section has its property, its use, okay? So what is electro? Let's go to electro first. Let's go to the file first, right? So when people bring a wafer to you, the first thing is that they have to tell you where to find the device. Because you want to do measurement, the wafer has so many devices. This is just like what it is doing. It tells you where is the device. You see it is n1_msh.tdr. So you know that it has to read this structure to do the simulation. And then the rest is that you have to specify what kind of output you want to have, and then where you want to save the output, right? For this, you can read the HTML tutorial to understand more. But the file session, the most important thing is to tell you where to find the structure to do the simulation. Now, you know where to measure the wafer, which device to use. But then for each device, it has many paths, right? If you need to probe the gate, probe the drain, or whatever. Right? So you also need to know where are the electrodes. And these are the contacts that you define in SDevice, in SProcess or structure editor. So then with this, we say, okay, for the source, initially we put the voltage equal to 0 volt, and drain to 0 volts, gate to -1 volt, and substrate to 0 volt. Okay? And similarly, you can also say we have a thermal, because if you want to do some self-heating simulation, you want to see how the temperature changes, you also need to add the thermal contact, but you can ignore it for now, right? So just like wafer measurement, as I said, now you know where to find the structure by using the file session, and then you know what contact you need to probe, and this is in the electro section. Now, when I go down, I see another section called physics. Physics is that now this is a simulator. You need to tell it what kind of physics to turn on, right? So you can turn on Fermi-Dirac statistics, band gap narrowing, high field saturation, recombination, right? So these are the physics you need to learn, but they are too much. So at the beginning, you just copy the template and play with it, okay? And then you have a procession. This procession has no effect on the simulation. It's just to tell what kind of data you want to save at the end of the simulation. Right? Let me try to open a file and show you what is saved there. Again, my network, this machine is not doing well. So let me open now first. Right? So just now we already opened, in the SVisual, I show you how to open the PLT file, right? At the same time, it also saves a snapshot of the simulation after everything is finished. You see that I can plot electric field, distribution of electric field, the total current density. Right? I zoom in, and then maybe the best is let's look at the electron density. This is in the on state. You see that under the channel, it has inverted a lot of electron, right? So that is also that then what to save is determined by this plot session. Okay. Now there's another section called math section. These are for numerics. Again, you don't need to know that for now, but usually copy the defaults and run the simulation. When you run into convergence problem or any issue, you can discuss with me and then I will tell you how to improve. Finally, as I said, this is just like a wafer measurement. Right now you know where to probe it, you know what physics to turn on, but then you have to tell the machine how to measure it. What are you trying to measure? And this is exactly what you do in the solve session. You always start with an initial solution. So you will say, I want to solve 3 equations, the Poisson equation, the electron equation, and the Hole equation. And you solve them together. After that, you will do a ramping. You ramp the drain voltage from 0. Remember, we start with 0 at the here. We say we start with drain voltage equal to 0, right? So I'm going to ramp it from 0 to 0.1 volt. So at this stage, what is the voltage when this finish? It will be VG at -1 volt and then drain at 1.1 volt, right? So this is in off state. But after that, then we are going to ramp the gate from -1 volt to 2.2 volt. That you will get an IDVG. Okay? So SDevice input file is actually not that complicated, right? You don't need to do it from scratch. Just copy from somewhere else, and then as long as you understand what each block does, that will be okay. And then you modify accordingly for your purpose.